Video, we're going to talk about one of the most fundamental aspects of mechanics, which is modeling the motion of objects with constant acceleration. And we're going to start by just looking at motion in a straight line. So this really is the next step on from what you might have done in the past where you had constant velocity. So what we really want to look at in this video is the difference between what you already know in the situation of constant velocity and more advanced high school level physics where you have motion in a straight line with constant acceleration. This is definitely not the same as what you know in relation to constant velocity, so we need to be able to distinguish between these two cases. We're also going to learn how to apply the appropriate kinematic equation to solve problems involving motion in a straight line. And that could be either with constant velocity or constant acceleration. So what you might have seen in the past, in your earlier years at high school, is something like this, a distance time graph. And you have a straight line, right? And from this you should have learned that the speed, or the velocity, but the speed specifically is the slope of this graph, right? So it's just the change in this distance divided by the time. So in this case, if you got a flat line, then you'd say that it's not moving, right? The distance is not changing, so the distance is flat. And so therefore, there is no velocity, or it's stationary. And then you can have a negative velocity where the distance is decreasing over time. Right? So all of these are constant velocity cases. Each and every one of these cases. Now we don't talk about these changes, these points here don't count, but everything else you should be fairly familiar with. And in all of these cases, the acceleration is zero. Doesn't matter if it's going up, if it's going flat, or if it's going down. As long as it's in a straight line, it will always have a zero acceleration, because the velocity is just the slope of this curve, so it's a straight line. But what about this? What's the velocity here? Well, that's a bit of a trick question, actually, because the velocity here is the gradient or the slope at this point, which if you look at it right at the 0 point, the gradient would actually be flat. So the gradient would be zero. Whereas up here, the speed or the velocity would be very high, right? Because it's almost a vertical line straight up. So the velocity here would be zero. The velocity here would be very, very large. So we can't say that there is one single velocity, right? In this case, we actually have to plot a graph of velocity versus time, right? Before it was distance versus time. This is a totally different graph. So here you can see the velocity starts at zero, but it increases over time. And in this case, the slope of this curve is actually the acceleration, not the velocity. So here we can see that we start with the velocity of zero, which is our initial velocity, and we end with a high velocity Vf. So once you start dealing with acceleration, you can no longer refer simply to velocity. You have to refer to the initial and the final velocity, right? The velocity at any point in time is going to be different than at any other point in time, right? Every single point on this curve has a different velocity. But in general, we refer to the initial point and the final point. So, now we can compare the actual equations for the two different cases. So what do we have for constant velocity? Well, there is no acceleration. So all we have is the velocity, which is equal to the distance over the time, right? This is the only equation we really need to worry about. Whereas, in the constant acceleration case, we have an acceleration term, we have an initial velocity, we have a final velocity, and we have a distance and a time. So really, we have two extra terms because we have two different velocities and an acceleration. Now, in my country, New Zealand, we will refer to initial velocity with a subscript I, VI. In other countries, you might have it written as U or V naught. But basically, when I say the VI, that means the initial velocity, and VF means the final velocity.